the calorimetry objective 2 question number 1. That is, the heat capacity of a body depends on A. The heat given, B. The temperature raised, C. Mass of the body, D. Material of the body. And here, first of all, to answer this one, we should know about that what is meant by the heat capacity. Heat capacity or thermal capacity means the amount of heat which is required to raise the temperature of body through 1 degree centigrade. This is known as the heat capacity or thermal capacity. So H is equal to delta Q by delta T. So units, CGS system, calorie by degree centigrade, SI system, joule by Kelvin. Here, specific heat capacity, we know that is the amount of heat which is required to raise the temperature of unit mass through unit degree centigrade, that is 1 degree centigrade. S is equal to delta Q by M delta T. So here delta Q is equal to MS delta T. So here from 1 and 2, here from 1 and 2, what is that here? First equation. H is equal to delta Q by delta T. Here what is delta Q is equal to MS delta T. So here H is equal to MS delta T divided by delta T. So rise in temperature gets cancelled. So here what is that? H is equal to M into S. Remember this one. Here in this equation, heat capacity depends on the mass of the substance and also depends on specific heat. But where the specific heat depends, it depends on the nature of the material. So that means in these options, the amount of heat given, heat capacity does not depend. And the temperature raised, it is also does not depend. On which factors it is depends? On the mass of the body, here mass. And another one, what is that? Nature of the material. So option C and D are the correct for this question. Here, the question number 2. The ratio of specific heat capacity to molar heat capacity of a body, option A, is a universal gas constant, depends on the mass of the body, depends on the molecular weight of the body, and D is dimensionless. So to solve this one, first of all, specific heat capacity, molar heat capacity formulas. So first, specific heat capacity represented by means of S is equal to delta Q divided by M into delta T. This is the first one. Next, molar heat capacity, that is represented by means of C is equal to delta Q divided by, this is number of moles, that is N into delta T. This is second equation. Here, the ratio of specific heat capacity to molecular heat capacity. So that means equation 1 divided with 2. So that means S divided by C is equal to delta Q divided by M into delta T divided by delta Q divided by N into delta T. But here what happens? Delta Q divided by M delta T into N into delta T divided by delta Q. Delta Q cancel, delta T cancel. But here, since we know number of moles is equal to mass divided by molecular weight. So I am substituting here N divided by small m, but N means small m divided by here small m into 1 by m. M cancel, here 1 by m. S divided by C is equal to 1 by m. The ratio of specific heat and heat capacity, that is 1 by m. Check the option 1. Is a universal gas constant? No. Depends on mass of the body? No. Depends on the molecular weight of the body? Yes. Is a dimensionless? No, molecular weight, it is there. So that's why the correct option is C. Here, the question number 3. If heat is supplied to a solid, its temperature A must increase, B may increase, C may remains constant, D may decrease. To answer this one, first of all, we are taking solid. Solid is nothing but just solid ice cubes I am taking. So here, solid ice cubes I am taking here. Ice cubes are taken in a beaker and insert one thermometer, and it must be heated by means of the spirit lamp, and it is continuously heating. Then what happens here? Slowly the temperature raises to some particular extent and reaches to 0 degrees centigrade. All the ice must be converted into water. That temperature remains constant. So here it can be represented like this. Observe the graph. So initially the temperature of the ice, that is minus 5 degrees centigrade, and when this is the time axis and this is the temperature. Whenever we are supplying the heat continuously, first the temperature rises to 0 value, that means 0 degrees centigrade. Then afterwards its temperature completely constant. Then afterwards its temperature raises to some particular extent, that is nearly 100 degrees centigrade. Then afterwards this temperature remains constant. Then afterwards the temperature rises. So that means what happens in this case? First, when we are supplying the heat, temperature raises, then afterwards remains constant, then again raises, then again remains constant. So that means what happens in this case? Here must increase is wrong, may increase. So here may increase here and increase here. So that also correct. And may remains constant. Here in this remains constant and here also remains constant. And may decrease, never possible here. So that's why what happens here? Option B and C are the correct for this question. Here the question number 4, that is the temperature of a solid object is observed to be constant during this period. In this period, what happens? A, heat may have been supplied to the body. B, heat may have been extracted from the body. C, no heat is supplied to the body. And D, no heat is extracted from the body. Here, first of all, we have to understand the question clearly. What is that? The temperature of solid object is observed to be constant. That means the temperature of the object is constant in certain period. In that period, what happens? Temperature remains constant means, suppose if the body is heated, that means if your body is heated, then its temperature remains constant up to some particular extent, where one phase of matter changes to other phase of matter. Liquid changes to gas or solid changes to liquid. So in that time what happens? Temperature remains constant. That means in that case heat is supplied or not? Heat is continuously we are supplying even though the temperature remains constant. During that time what happens here? Some amount of heat must be extracted. So that's why what are the options here correct here? Heat may have been supplied to the body. We are giving the heat continuously. And heat may have been extracted from the body. That is also possible. But C and D are not possible. This is the solution for question number 4. Here, the question number 5. The temperature of an object is observed to rise in a period. In certain period, the temperature of the body raised. In this period, what happens? A, heat is certainly supplied to it. B, heat is certainly not supplied to it. C, heat may have been supplied to it. D, work may have been done on it. So here, which of the correct option here? So in certain period of time, the temperature raised. Whenever the temperature raised, heat may have been supplied to it. So that means C is correct. Then what happens here? If you are supplying the heat, some amount of work may be done in that particular body. So that means here work may have been done on it. That means according to Joule's law, work may be done on supplying some amount of heat. So what are the options for this one? C and D are the correct options for question number 5. Here, the question number 6. Heat and work are equivalent. This means option A. When we supply heat to the body, we do work on it. B. when we do work on a body, we supply heat to it. C, the temperature of body can be increased by doing work on it. And D, a body kept at rest may be set into motion along a line by supplying the heat to it. So which option is correct? First of all, we will check the first option. That is, when we supply heat to a body, we do work on it. It never be possible. Why? Because when we supplying heat to the body, it is effect to the internal. That means the temperature raises or the temperature remains constant. But what happens here? We do work on it, it is not possible. So that's why it is not the correct option. And B, when we do work on a body, we supply heat to it. Heat is a form of energy. Work is nothing but force into displacement. So here, this option is also not correct. Option C, the temperature of body can be increased by doing work on it. If we are doing the work on the body, we can increase the temperature of the body. It is the correct option for this one. And D, a body kept at rest may be set into motion along the line by supplying heat. If we are supplying the heat to the body, it never be moved from one place to another place. So what is the correct option here? C is the correct option for this question.